Hello students, today we will solve numericals based on electric power and energy consumed by the electrical appliances. So here is the first question I have written on the board. A torch bulb is rated at 2.5 volt, 500 milliampere. Find its power and resistor. So here we have a torch bulb, given data. So here we have a torch bulb which is having the ratings, that is the voltage is 2.5 volt and current is 500 milliampere. We have to find its power and also resistance, right? Okay. We know that power is equal to V into I, right? Now look at here. The value of current, it is given in milliampere. So here we need to convert this one milliampere to ampere. This is equal to 500 as it is. Milli means it is 10 raised to minus 3. 10 raised to minus 3 ampere, right? Now this can be written as, let's suppose that if I written 0.5 into 10 raised to minus 3 into 10 raised to 3. What I have done? Here nothing means 0.0. I have shifted this one point after 3 digits. So whenever you are taking the point in the backward direction, you need to multiply with the number 10 raised to, that is how much digit you have taken in the backward direction. So here I have taken 3 digits. So here 10 raised to plus 3. If I move the point in the forward direction, that should be taken 10 raised to minus 3. Okay. So here why I have done like this? Because in order to cancel these two terms. So here current, it is 0.5 ampere. Now you can easily simplify this one. Therefore P is equal to V is, it is 2.5. I is, it is 0.5. Now multiply these two numbers. It is 125. So here after 2 digit we have the point. So it is 1.25 watt. So the power is 1.25 watt, right? Now similarly we have to calculate the resistance of the torch bulb. Now the relation between power, resistance and the current, we know that P is equal to V square divided by R, right? Therefore R is equal to V square divided by P. This is equal to V, how much? It is 2.5 square divided by P is how much? It is 1.25. It is 1.25, right? So this is equal to, now you can simplify this one. It is 625. Take the point divided by 1.2. Cut these 2 points. Now you will get now here 125 ones are 125, 125 5s are 625. Therefore resistance is 5 ohm. The next problem is, which of the two has greater resistance? A 1 kilowatt heater or a 100 watt tungsten bulb, both marked for 230 volt. So here we have two electrical appliances, given data. So first thing, the first electrical appliance, we have heater. That heater is having the power 1 kilowatt, and we have one more electrical appliance, that is the tungsten bulb, which is having the power 100 watt, right? And these two electric appliances both marked for 230 volt, which means the voltage is 230 volt. 230 volt. We have to calculate in between these two electrical appliances which is having greater resistance. So let's suppose that the resistance for the heater is R1 and resistance for the tungsten bulb is R2. Fine. So this is the given data. Right. Now solve for the resistance. Therefore, R1 is equal to, I can write V square divided by P, because we know the relation that P is equal to V square divided by R. So I can take R is equal to V square divided by P. This is equal to, V is how much? It is 230 square divided by P is how much? It is 1 kilowatt hour. 1 kilowatt. So convert it into watt, because here we need to take the values in watt. So 1 into 1000. Okay, so this will be equal to 1000 watt. This is equal to 1000 watt. Now 230 into 230, I can write like this, divided by 1000. 0 0 0 0, both are get cancels together. This is equal to 23 into 23, it is 529, divided by, in the denominator we have 10. Okay, so here in order to remove the denominator as 0, I need to give the point in the numerator after one digit. So this is equal to 52.9 ohm. So the resistance for the heater is 52.9. Now we have to calculate the resistance for tungsten bulb. Okay, this implies that R2 is equal to V square divided by P. Okay, this is equal to 230 square divided by, power is how much? Power for the tungsten bulb is, it is 100 watt. It is 100 watt. This is equal to 230 into 230 divided by 100. Okay, right. So 0 0 0 0, both are get cancels together. Now 23 into 23, it is 525. So the resistance of the tungsten bulb is 529 ohm. So hence, in between heater and the tungsten bulb, which is having the highest resistance, that is the greater resistance. The greater resistance is, that is tungsten bulb. So here tungsten bulb has greater resistance, that is 529 ohm. So hence here we have solved the problem. The next problem is an electric kettle rated at 220 volt 2.2 kilowatt works for 3 hours. Find the energy consumed and the current drawn. So here we have a electric kettle which is having the power ratings. So given data, voltage is equal to 220 volt, power is equal to 2.2 kilowatt and which works for 3 hours, that is time is equal to 3 hours. We have to find energy consumed, that is E is equal to question mark, and we have to find the current drawn by this electric kettle. So I is equal to question mark, right? So we know that E is equal to P into T. This is equal to P is equal to how much? It is 2.2 kilowatt into time is equal to, it is 3 hours. This is equal to, multiply these two numbers, you will get 6.6 kilowatt hour. So energy consumed by the electric kettle is 6.6 kilowatt hour. And similarly we have to find the current drawn by the electric kettle. So here we know that power is equal to V into I. Therefore I is equal to power divided by voltage. This is equal to, what is the power? We have the power 2.2 kilowatt divided by voltage. Voltage, how much we have the voltage? That is, we have the voltage 220 volt, right? Now as we are calculating the electric current, so here you look at here, this value for the power, it is 2.2 kilowatt. So convert into watt. This is equal to 2.2 into 1000 watt divided by 220 as it is. So just what I have done, in order to convert kilowatt to watt, I have to multiply with the number 1000. So this is equal to, multiply these two numbers, you will get 2200 divided by 220 as it is. 0 0 both are get cancels together. Here 22 ones are 22, 22 ones are 22. So this is equal to, you will get 10 ampere. So the current drawn by the electric kettle is 10 ampere. So hence we have solved the problem. The next problem is, an electric motor takes 5 ampere current from a 220 volt supply line. Calculate the power of the motor and electrical energy consumed by it in 2 hours. So this is the question. Given data, we have an electric motor which takes 5 ampere current, I equal to 5 ampere, from a supply, that is voltage is 220 volt. We have to calculate the power of the motor, P equal to question mark, and also we have to calculate the energy consumed by the electric motor in 2 hours. E is equal to question mark and T is equal to, we have 2 hours. So this is the given data. We know that power is equal to V into I. This is equal to voltage, it is 220, current, it is 5 ampere. This is equal to, multiply these two numbers. Multiply these two numbers. 220 into 5. 5 0 0. 5 2 is 10. Carry 1. 5 2 is 10. Plus 1. 11. So here we have 1100 watt is the power of the electric motor. So next we have to calculate for the energy consumed by the motor. We know that E is equal to P into T, right? Now look at here, we have the P value in watt. Now convert this one watt into kilowatt, because energy consumption always calculated in kilowatt. Therefore P is equal to 1100 divided by 1000. Okay, now in the denominator we have 3 zeros. So in order to remove these 3 zeros, I have to give the point in the numerator after 3 digits. So 1 2 3. So this is equal to 1.1 kilowatt. Right, now put the value 1.1 kilowatt into hours is, that is 2 hours. 2 hours. This is equal to, it is 2.2 kilowatt hour. So the energy consumed by the electric motor is 2.2 kilowatt hour. Hence we have solved the problem.